In this video, I'm going to talk about solving linear inequalities. So before I start talking about linear inequalities, I like to remind us about inequalities in one variable. So that could be something maybe you saw even in 7th grade, something that looks like 2x plus 7 is less than 15, and you'd be most likely asked to solve for x and probably even show your solution on a graph. So if you went through to solve this, you would subtract 7 on each side, you'd probably be left with 2x is less than 8. Going through to solve that, you would then want to divide each side by 2, which then would leave you with just x being less than 4. And then again, back in 7th grade, they probably would have asked you to graph your solution. You figure it's x is less than 4. So that means that your answer is going to be any number less than 4. So like 0, 1, 2, 3. It could also be, say, pi. It could be negative numbers. Could be fractions and decimals, but any value less than 4. And notice that your answer would not include 4 because it's just less than 4, not less than or equal to. So if you went to graph that, then you would plot your 4, and then hopefully you would know you would be doing an open circle on 4 because you're not really including that because you just had less than, not less than or equal to. If it was less than or equal to, then you could do a filled in circle, and then we would be shading to the left-hand side to indicate that our solution is anything less than 4. So and we could actually even write our answer in interval notation, which would then look like negative infinity to 4. And again, neither of those would be included. So then when we go to look at linear inequalities, you're going to see then two variables. So for example, we could see something like y is less than 1/2 x plus 3. And you're seeing it essentially is falling into our slope-intercept form, except for in place of where we usually would have the equal sign, now I'm seeing a less than symbol. So I can tell it's an inequality rather than equation again because I have the less than symbol. But so if I was going to go to solve this, then I already have y isolated, but then I'm going to need to graph it kind of like how I had to graph my inequality that was in one variable. But then you figure I can't just do a number line because now I have two different variables, an x and a y, so then I'm going to need to have an xy grid or like a coordinate plane. So when I go through this, I'm going to want to look at what is my slope and what is my y-intercept, just like when you would graph a normal line in slope-intercept form. So hopefully you're seeing here your slope would be 1/2, y-intercept would be 3. So the first thing you can do is plot your y-intercept. Again, that would go on the y-axis right at 3. So then from there, you can start using your slope with the rise over run to plot other ordered pairs. So I know that my slope, it's 1/2, so then both the 1 and the 2 are positive, so that would be like 1 up and then 2 to the right, and I can plot as many points as I can that way, going 1 up and then 2 to the right. In addition, though, to going 1 up and 2 to the right, you figure I can also do the opposite of that. So the opposite of up is down, and the opposite of right is left. So that would be 1 down and 2 to the left, kind of like -1 over -2, which is still 1/2. So then I'm also able to go 1 down and 2 to the left. And then that gives me all of the points I need, but I'm still going to need to connect them. Now, the thing is, though, is usually when I think about an inequality, I have to determine, am I actually going to include, either the main point, like we had in the other one, we had an open circle, a closed circle, but here you figure we just had a less than symbol. So I actually do not want to include then the points that are actually on the line. Now, again, with the one variable, I could do an open circle, but I can't do an open circle here because I'm graphing a line, not just a circle. So then to show that I'm not including the line, I'm actually going to graph the line dashed. So instead of showing like a solid line, I'm going to make it dashed. The other thing that I have to do still is my shading. So there's different ways that you could figure out the shading, but the main one that I want to show you guys is picking an ordered pair and then substituting it into our inequality. So I like using 0, 0 whenever I can because it's easy. The only time I can't use 0, 0 is if my line actually goes through it. But so my line doesn't go through 0, 0 here, so I can use that. So I can look at 0, 0. I know 0 is both the x and the y, but so I can substitute in 0 for y and 0 for x then. And when I go through that, okay, 1/2 times 0 is 0, and then 0 plus 3 is just 3. So I'm left with this statement that reads 0 is less than 3. And I know that that's true, like 0 is less than 3. So then I'm going to want to shade on the side of the line that 0, 0 is on. So 0, 0 is here, so I'm going to shade below the line. So again, I'm shading the side of the graph that the ordered pair falls on. So then my final solution to this linear inequality will look like this. And I'm seeing again that I have the line graphed. I knew that it was dashed because I just have a less than symbol, not less than or equal to. So that means that the points that actually fall on the line are not solutions, but everything in the shaded area below the line is a solution. So if I was to take, say, the ordered pair like 4, 3, that's a solution. It's in the shaded area. If I substituted 4, 3 into the inequality, I would get a true statement. Same with like 6, 5, or I could look at 8, 5, or I could look at 2, -2. Any ordered pair in that shaded area is a solution to my inequality. I thought we could try one more practice problem. So this one reads, y is greater than or equal to -2/5 x minus 1. So again, I'm seeing a linear inequality with two variables. So the solution will be graphed on a coordinate plane, an x and y coordinate plane. So then the first thing that I'm going to want to do is graph my line. So I'll identify my slope and my y-intercept. And I can start graphing. I know my y-intercept is going to be -1. And then when I look at the slope, I know my slope is -2/5. So you do have to be a little bit careful here. Say I start thinking about it as -2/5. The negative tells me to do 2 down, and then +5 would tell me to do 5 to the right. And then I can figure out the opposite of that as well. So that would be 2 up and 5 to the left. Opposite of down is up. Opposite of right is left. You also might come up with 2 over the 2 up and 5 to the left if you thought about the -2/5 as 2 over -5. But either way, for your two sets of rise over run, you're going to go 2 down, 5 to the right, or 2 up and then 5 to the left. So I graphed my 2 down and 5 to the right first, and then again 2 down, 5 to the right. And then I can also go 2 up and 5 to the left. Oops, and I have one point on there that I wasn't supposed to. I can figure out if I'm going to need to graph my line is solid or dashed. But here I have greater than or equal to. So because I have the equal to, that means that the points that are on the line will be solutions. So if I was thinking about an inequality in one variable, that would be like a filled in dot. But so here then, I'm just going to draw the line as solid. Remember, again, if it was just greater than, that would be dashed, but it's greater than or equal to, so I'm making this a solid line. So I've taken care of my line. So the next thing that I need to do then is figure out which way I'm going to be shading. So then I like to guess or pick a random ordered pair and then figure out if I get a true statement or a false statement to determine which side of the graph I'm going to shade on. So maybe I use the ordered pair 0, 0. That's pretty easy. So then I can substitute the x and y into the inequality. Again, I had y is greater than or equal to -2/5 x minus 1. So I know 0 is x, 0 is y. So I substitute 0 in for y and 0 in for x. -2/5 times 0 is just 0, and then 0 minus 1 is -1. So I'm left after I substitute in with 0 is greater than or equal to -1, and that's true. 0 is greater than -1, so that's a true statement. So that means that I'm going to need to shade on the side of the graph that 0, 0 falls on. So in this case, it happens to be above the line. So I'm shading on the side with 0, 0. So I know that 0, 0 is a solution, but really anything in the shaded area is a solution. And even the points on the line here are a solution, again, because I had greater than or equal to, and I'm showing that with the solid line. So again, I know that any point in the shaded area is a solution. So if they asked you, say, if I don't know, like -5, 4 was a solution, yes, it is. It's in the shaded area. Also, if I substituted in the x and y, I would get a true statement. A few reminders about graphing linear inequalities are here. If you want to pause the screen to read through them yourself, you can. But if the inequality that you're trying to graph is ever not in slope-intercept form, like say it's in standard form, you can always change it to be in slope-intercept form if you'd like to follow the process that we just showed in the video. If your inequality has a less than or a greater than symbol, that would be a dashed line. That means that the points that are falling on the line are not actually solutions to the inequality. And again, we represent that as a dashed line. If you have a less than or equal to, a greater than or equal to, then that line would be solid, and that's showing that those points then are solutions to your inequality. Another thing that I wanted to mention or give the reminder of is just that when you're choosing where you're shading, we showed in the video that you can pick an ordered pair, substitute it into the inequality. If you get that the statement is true, then you're shading on that side that has the ordered pair. and then everything that you're shading is a solution to your inequality. If you ever got that the statement was false, then you have to shade on the opposite side. So I also want to mention, though, that you may have noticed as we were doing that when you had a less than symbol, if your equation or your inequality was in slope-intercept form, if you ever have a less than, you're going to be shading below the line. If you ever have a greater than in slope-intercept form, you're going to be shading above the line. So you can use that too, or you can kind of use that to check. Anyway, I hope this video was helpful. Thanks for watching.